Okay. Happy Monday, everyone, or whatever day you're watching this. Hope you're staying well and safe. I'm going to finish up our last bit of notes for this chapter. This is a new chi-square test, except it's not really new. It's going to be exactly the same. The only small difference, is that because of the way that we're collecting the sample that we're making, we have to state our null and alternative a little bit differently. That's going to be the only difference. It's a different kind of chi-square test, has a slightly different name, slightly different null and alternative. Everything else is going to be the same. Okay, so the example that we're going to look at is from a sample that is looking at whether people with certain levels of anger developed a heart disease. And what we're looking for is whether these two variables have anything to do with each other. And so this is going to be called a chi-square test of association. We're looking at whether these two variables have anything to do with each other, whether there's an association between the two. That's how we're going to state out the null and alternative for this. Okay, and so one way we can do this is, just like before, we can look at the actual percentages and make a chart. So if we do that, let's look among the people who had low anger, who had moderate anger, and who had high levels of anger on this test that we did. And we can look at, there are small differences in the percentages. And the question that we're trying to answer is, are those percentages enough for us to actually say that these two variables are related, that they have to do with each other? There's a trend, but isn't enough to say that these are actually related. And we're going to do this with a chi-square test. Okay, and we're going to look at a relationship. Like I said, what we're looking for is there an association between these two variables? Do these two variables have anything to do with each other? So it's called a chi-square test of association. It can also be called a chi-square test of independence, which in that case you would state the null and alternative slightly differently. Okay? Independence means, well, it means the same thing. It means the two variables don't have anything to do with each other. So you can either state the null and alternative this way, which is that there's no association between the two variables. I prefer this way because it more closely matches the null and alternative that we usually say. But the same way to say that there's no association, that the two variables have nothing to do with each other, would be that they're independent. So you could also say my null hypothesis is that the two variables are independent, and then the alternative is that they're not independent. If you're calling it association, then your null is that there's no association. Your alternative is that there is an association between these two variables. Okay? And this question comes from us collecting the data from a single sample. Okay? Versus if you look at the examples we were doing before, we were looking at either separate samples or we were taking the sample and splitting them into three groups like an experiment. Okay, so we looked at using different drugs to cure addictive behavior. So we took them into three different groups. Or we looked at party affiliation from two separate samples of what kind of phone they had. And so those were separate samples or splitting them into separate groups. That was our chi-square test for homogeneity. And so a null and alternative looked a little bit different. When we go from a single sample and are recording two different variables, then we're asking, do these two variables have anything to do with each other from our single sample? Okay, so if you have a single sample, you're doing a chi-square test of association or independence. And this is what your null and alternative structure is going to look like. everything else we're about to do is going to look exactly the same as we've been doing before. Okay? For example, if you're looking at degrees of freedom, it's still going to be number of rows minus 1 times number of columns minus 1. So if we're looking at the data back here, degrees of freedom, well, there's going to be 2 rows and 3 columns. So 2 minus 1 times 3 minus 1. That will give your number of degrees of freedom. Number of rows minus 1 times number of columns minus 1. That's the exact same as we've been doing. Okay, and here's what's in front of you. Formula is the same, observed minus expected squared over expected. And the way we're about to put it in the calculator is also going to be exactly the same. It's going to be from the exact same menu. We're going to use the matrices just like we were doing. Okay, so let's try that out. There's our expected counts. We'll get them in the calculator in just a second. But again, here's our null and alternative. Our null is that there's no association between, and then you say your 2 variables. And then your alternative is that there is an association between these 2 variables. So in this case, there's no association between anger level and heart disease in this group. And the alternative is that there is an association between anger level and heart disease. 0.05 alpha level. Chi-square test for association and dependence. That's the name of the test. Conditions are still the same. We're coming from a random sample. Expected counts are at least 5. All right, and then we can do our usual 10 times sample size. Do we have anything else? Oh, I'll go back. Take a sip of water. Make sure you can get it written down. And then we'll move on. Step 3, we'll go to the calculator here. So just like we did before, I've already got this in the matrix. You only need to put the observed counts. Once you have the observed counts, the calculator is going to fill in the expected counts. 2 by 3 matrix because we had 2 rows and 3 columns. So now that we've got this in data in matrix A, we're going to go stat tests. And it's going to be a chi-square test. Observed we have in matrix A. Expected we're going to put in matrix B. And there's our p-value. Hey, don't forget that scientific notation. That means it's 0.000322831117. Okay, and then your chi-square statistic, degrees of freedom is 2 because it's rows minus 1 times columns minus 1. Okay, and if you go, this would be something you would put in step 2. You'll notice that matrix B is filled out now. So I can go into edit and see what's in matrix B. Here are my expected counts. So we can write those all down and we can say that they're all at least 5. Okay. So let's go back. We had our conditions. Oh, this way. There's the formula. Again, first 2 terms and then ... and then write the last term. If you're using the table, you're looking at degrees of freedom 2. So we know that the p-value is very small. So because p-value is less than 0.05, rejecting the null hypothesis and conclude that anger level and heart disease are associated, that there is an association between the 2 variables. Rejecting the null, concluding the alternative. Okay, and that's really it. The process is pretty much the same as we've always been doing. Conditions are the same, formula is the same, the way we put it in the calculator is the same. The only difference is the null and alternative, and we're doing that because we're looking at one sample. Okay, so here are the two chi-square tests we have in this section of the chapter. So overall, we've got 3 different chi-square tests. Okay, our first one, it was a goodness of fit test, and that was when we just had one variable that we were keeping track of. We were keeping track of the colors of the Skittles and the day of the week that you were born. And that was just one variable you were keeping track of. If you got one variable, then it's a goodness of fit test. End of story. When you got 2 variables that you're keeping track of, that's when you're looking at homogeneity versus association. And the key thing is chi-square test of association or chi-square test of independence is from a single sample versus homogeneity when you're coming from 2 different samples, or if you're coming from an experiment where you're splitting your sample into 3 separate groups or separate treatments. If you're just taking a single sample and you're recording the variables with that one sample, then that's going to be your chi-square tests of association. All right, so hopefully you have the homework assignments and you picked up your review at some point this morning. And my plan is later this week, I'm going to post out something that goes through some of the free response questions that I gave out. We'll do that later this week. I'll send you more details when we're getting closer to doing that. Okay, so that's what you want to look at. You should be able to do all the homework now. Let me know if you have any questions. I hope that you're taking care of yourself, and I will talk to you more soon.